Assalamu alaikum. Today we're gonna talk about our third experiment for instrumentation 1 lab, which is basically about the pressure switch. So this is our outline for today's experiment. First, we're gonna introduce what we mean by pressure switch. We're gonna define it, and then we're gonna talk about a little bit how does it work in principle. After that, we're gonna define the difference between normally open and normally closed, and later on we're gonna see the connection in experiment. Our objective for this experiment is to be familiar with the pressure switch. We're gonna define it and to see how does it work in principle. After that, we're gonna see the difference between normally open and normally closed and how we distinguish between them. After that, in practical experiment, we're gonna learn how to connect the pressure switch with the Bmax and how to find how to do the experiment for it. So pressure switch basically is a kind of switch. If I want to define it, it's just an electromechanical device that changes the state of connection in the circuit by applying certain pressure. So if you're familiar with the typical switch that you have in your home, I have switch to turn on the light, turn off the light, but I'm gonna do it this action by hand. In our case here, I'm gonna depend the action by applying some certain value of pressure, and this is basically the definition of pressure switch. So you can see that it is only a typical switch that's made for industrial purpose, and we're gonna apply some pressure on it in order to change the state. Once we talk about changing the state of the circuit, we mean that make it off to on or on to off, depending on the first state of the circuit. So based on that, I'm gonna introduce two definitions here. The first definition we have is the normally open, which is basically means the original state of your circuit is open. So the circuit is connected and start as open, or in the case of the lamp is off. So this is like basic definition of the normally open. Normally closed, when you talk about normally closed, I'm gonna connect my circuit such that the original state of my circuit is closed, or in other way, I can build my circuit to be working all the time, and whenever I want to do an action, it's gonna turn off this. So a typical example for it is the pump in your home, the water pump. I want all the time to be work, unless if I don't want, which is to save the energy, and this is the case of normally closed. So we have different way of connection for the circuit depending on the application, and we need to choose which connection that you're gonna do for this switch. This is applicable for pressure switch and other switches. Today we're gonna only cover about the pressure switch, since our topic we start to talk about the pressure, and we're gonna continue with the pressure. So this is a simple diagram of the pressure switch, and we're gonna define its element here, and we're gonna learn how does it work in principle. So so you can see that it has two scale. The main scale which is the main. Second scale is the differential scale, and you can see it has two spring. I can adjust it here by some screwdriver based on how to set my upper limit and lower limit. I'm gonna talk about it in a minute. And we have here three terminal. The first one is common, normally open, normally closed. This is not always the order, but this is the typical terminal that you're gonna have in your pressure switch. And of course here we're gonna have the pressure inlet. So this is where you're gonna apply your pressure. You're gonna connect your hose here, and inside this block we're gonna have some diaphragm that it keeps the pressure level until it keeps the pressure until some level in order to push up the let's say nose of this brusher. So this is typical element of the brusher switch. I'm gonna go one by one in order to understand the principle of working of this brusher switch. I hope to have moving image, but I didn't find one, so I just draw this in order to understand how does it work. So basically we have three terminal: common, normally open, normally closed. As I explained before, if I want to connect normally open, which is mean the original state of my circuit is open circuit, so we're gonna connect it here with the common, and I'm gonna show you later the diagram for how to connect. But let's agree that for normally open, the original state I start the circuit as open circuit. For normally closed, I start the circuit as closed circuit. So if you connect it here, the circuit is to start as a closed, and you can see that the contact of the brusher is already connected with the normally closed. That's why if you connect your circuit, you're gonna see that the circuit is on, or the circuit is complete and closed. So this is related for the terminal, and we're gonna talk about it in detail in the next slide. But let's say agree on this is the terminal for the connection. Common is gonna be always there, normally open for open circuit, normally closed for original for circuit to be considered closed from the beginning. We have two scale here. The first one is the main. This main scale, we're gonna identify my upper limit, and yeah, I can change it by some screwdriver in the pressure switch. So whenever I want to raise it up, this link with the spring, we're gonna go down or move up depending on the how you want to set the pressure. Do you want it less or more? So I'm gonna change it from here. For the differential, it's gonna tell us the lower limit of my pressure. I want to go back to the original connection. So once I adjust this node is gonna go down. So this is the related for the scale. The main for the up to set the upper limit, I can move this up and down based on my setting, and the differential to change the lower limit. Also gonna cover it in detail in the next slide. For this block, it has nodes connected to the main scale and differential scale, and start as is shown. This is not exact picture. I just draw simple one to understand the concept of it. So when you apply some pressure, the pressure stays here until it reaches some limit. After that, if the pressure reaches the desired limit, we keep the pressure here because sometimes we have some other factor affecting the process measurement, like temperature or vapor or any kind of factor that depend affecting the accuracy of the measurement. That's why you're gonna have this kind of room to keep the pressure, or less kind of trap of the water or the gas or whatever you want to measure. And once it reaches some certain level, we have an element called diaphragm أو زي الغشاء. يعني تغير زي الغشاء مطاطي هنا. If it's reached the desired limit، إذا وصل حد معين من البرشر، الغشاء هذا يتمدد و كيف أقول يدفع الوصلة هذه، حيث أن البرشر هيتغير مكانه من normally close إلى open، أغير الستيت من close إلى open. فكل ما زاد برشر يدفع وصلة هذه لتغيير نقطة التقاء الدائرة. So once you apply some pressure, this nose is gonna be moved and change the state from closed to open for this case. And once you want to reach the lower limit, you have to decrease it until some level, and after that, once it reaches this once you want to decrease, it's gonna apply the same thing. This diaphragm, we're gonna keep some pressure here, and once it's reached the required limit, then the nose is gonna go back to its original state. So this is basically the principle of working of the pressure switch. So in summary, I have main to set the upper limit for the pressure, and I have differential to set the lower limit for the pressure. For example, I want to the pressure to be on at 45 psi. So I need to supply the pressure switch to reach 45 in order to move this nose to the other contact. So if it's reached 45, it's gonna change the state. After that, for the lower limit, let's say that 20, then I have to decrease it to 20 in order to move back to this contact or the original state. So this is in principle how does it work. Regarding the upper limit and the lower limit, the upper limit we can find it directly from the main scale. If you are able to read the main scale value, you can set the upper limit. For the lower limit, you need to subtract the differential scale that you have in your pressure switch from the main in order to find the lower limit. So if you want to set to be 45, then you have to, if you want to set your upper limit to 45, then you have to set your main scale to 45. If you want to set so let's say that I want to set my upper limit to 45 psi, of course. Let's write it here. So this is my upper limit, which is the main 45. In order to make the lower limit 20, for example, then you have to set the differential scale to 25. Sorry, I hope this writing is clear. So yeah, 25. So 45 from minus 25 is gonna give me the 20. So this is how to set it in the scale if you are able to read the values. Otherwise, you're gonna use the precise measurement device like Pmax in order to set the exact value. So looking for this picture, it's only show you if you start. So this is considered, this side is considered normally closed, this side is considered normally open. If you start to connect your circuit with normally closed, so it stays closed until you reach to the upper limit, the one you set it in the main scale. Once you set it in the upper limit, it's gonna be open, and the one you connected with the lower limit is gonna be closed. So this two terminal, we're gonna switch directly at the same time. Once the upper limit reach, the close change to open, and the open change to close. Once you want to go back to the original state, then you have to decrease until you reach the lower limit. The lower limit, you can set it by finding the difference between the upper limit 45 minus the differential, which is 25 in our case. So if you decrease it until you reach the lower limit, which is 20, Then this terminal we're gonna go back to its original connection, which is normally closed, and the reverse way for the normally open. So normally open, it was open, then it comes close after you reach your upper limit. Then after that, if you want to go back, you have to come back to the lower limit in order to go back to the original state. So this is in principle how the difference between upper limit and lower limit, and how this connection is affecting, or how this connection is keep changing with the upper limit and lower limit. So this is a simple circuit of the connection of the switch. So if you want to connect your circuit with the lamp, if you start your connection with normally closed, so this is once you try to connect, the lamp will gonna start on, and once you reach to the lower limit, upper limit, the circuit is gonna be open, then the lamp is gonna be off. So this is the case for the normally closed. In the opposite way for the normally open, so this is what you saw once you start the connection with normally open. So obviously the circuit is not complete, no current reaching the lamp. That's why you can see that starts as off lamp. Once you apply some pressure, you reach to the upper limit, the switch is gonna go up until it reaches to this limit and the circuit is complete, then the lamp is gonna be on. So this is the difference between normally open, normally closed in circuit. Another difference between normally open and normally closed, in order to indicate which one is normally open, normally closed, you need to measure the resistance between the common and the normally closed terminal. So this is what you're gonna do at the beginning of your experiment. You're gonna use multimeter to measure the resistor between the common and normally closed. In order to find to see that it is normally closed, you have to have a very low resistance. I mean, like 0 resistor or 1 ohm, depending on the value. So maybe this is like low range, 0 to 10 ohm. This is considered low range of resistor. If you have your resistor value between these two numbers, it means that this terminal is normally closed. While if you try to measure the terminal between the resistor between the common terminal and the normally closed so this is open, should be changed, this is by mistake, normally open. Then in this case you're gonna see a high resistor value if you have accurate multimeter, or you're gonna see this symbol OL, which means open loop, and no or the resistor very high, which means the circuit is open. So this is in terms of resistor value. Low resistor, it means that these terminals are closed, and this should be the normally closed. So why we need that? Because normally open, normally closed most of the time is not indicated. You have to find it by yourself. So if you try to measure between two terminals the resistor, you're gonna see that for low resistor it means that I'm having normally closed. For high resistor I'm having normally open. And this is the experiment. Follow what we have in the experiment, and then I'm gonna ask you to fill this blanks once you start your experiment. So you're gonna start to measure the resistor between the terminal in order to indicate which one is normally open, normally closed. So you're gonna write down the order or the color of the wires on the multimeter or on the pressure switch. So for example, in my case, I'm gonna have here black wire, and normally closed I was I think thread. Uh, Sorry, I'm suffering with the writing here, but this is what I think I had in the video. So once you comes, try to write the color of the wires that indicate this is normally open, normally closed. So whenever you ask to connect in normally open, normally closed, you know which terminal that you're gonna use. Then you're gonna find the upper limit, lower limit, and based on these values, you're gonna tell me what's the main and what's the differential. This is it. It's very simple experiment, and best of luck.